All right. Hey, we are going to start our first actual physics unit here. And our first actual physics unit is going to be focusing on the theme of constant velocity. So, everything that we talk about in this unit, the little labs will do, the assignments, the formulas, will all deal with objects moving at a constant velocity the whole time. I find it's a nice little introductory type unit. It makes sure that we, understand the basics before we make anything too complex here. All right, so first thing we need to answer is what is the difference between speed and velocity? Because a lot of times we use those terms interchangeably, but when we're talking about science, they have specific differences here. So, speed tells you how fast you're going. Your car's speedometer is miles per hour. So, it is a distance traveled in a certain amount of time. If you drive down I 94 at 80 miles an hour, your car travels 80 miles for every hour it's traveling. So speed equals distance divided by time. Sorry about that. Velocity also tells you how fast you are going and in what direction you are traveling. That's the big difference, is that it has a direction attached to it. So it is 80 miles an hour south or 15 meters per second to the left, etc. there. So velocity is going to also be distance divided by time, but it's going to have that vector component to it. So how do we calculate that? This is the important part here. So a couple ways we can do that. We can find the slope of a distance versus time graph. I have a picture of that on the next slide. But if you graph the distance along the x-axis, sorry, time along the x-axis, distance along the y-axis, that chart should give you the the velocity of your object. And we use the equation that looks very messy, but we're using the equation, the change in distance divided by the change in time. That triangle is something that you're going to see a lot. That is the Greek letter delta, and that just means change. Okay, so when we're talking about someone running the 100-meter dash, their distance has changed 100 meters, and the time has changed 12 seconds. All right, and that gives us their velocity. Here's a look at that position versus time graph. So time's across that x-axis, distance is across that y-axis, or displacement rather. And so we can see that for every second, it is traveling 20 meters. Okay, so 10 meters. Take that back. For every second, it's traveling 10 meters. So we take whatever our change in position, so from 0 to 50, over the change in time, 50 over 5. So that's going to be 10 meters per second. So hopefully nothing too extreme here today. We'll make sure to get you an assignment that, sorry about that, that is practicing this calculating velocity here as we go.